Hi friends, welcome to our channel. Let's look at problem 3604, minimum time to reach destination in directed graph. So in this problem, if you read the problem statement and especially pay attention to this minimum time, it actually gives you strong hint for using Dijkstra's algorithm. So here, let me quickly read through it and analyze the problem and then explain the idea. So here we have a directed graph labeled from 0 to n-1, where n is the number of nodes. So the graph is represented by a 2D array edges. So given in a length 4 tuple list. So the first element is the start, and the second one is the end. The third one and the fourth one are the time interval during which the road can be used, right? So we start from the node 0, and then in 1 unit of time, we can do the following, right? We either wait or travel along an outgoing edge from the current node if the time in between this available to use period, right? So we want to return the minimum time required to reach the last node n-1. If it's impossible, return -1. So here, the impossible case, for example, you can see example 3. So this is impossible because there's no outgoing edge from 0, right? So you can actually analyze example 1 and 2. So it actually has some details. But here I want to comment. First, this problem is simplified due to the assumption that we can finish travel on each road as long as the time is in between start and end. So each road, the actual travel time is 1. So we just need to consider the wait time. Right? This is the one part. So another thing is about the Dijkstra's algorithm. So there are 2 main ingredients. So for example, you have a min heap, right? So this is the data structure. So another one is a relaxation. So here the relaxation is very straightforward, like in the hint, right? So hint 2 and hint 3 actually combined together gives you the relaxation, right? So with that said, I think we can go to the coding, and in between we are going to explain the details. First, I'm going to make a list, or you can use a set, which contains to use a flag variable 0 and 1 to demonstrate if a node is visited or not, right? So here we have a heap. So for this heap, we are going to store 2 things. So we are going to store the time and the node. So also we need to build this graph. So graph we can build using adjacency list. So for I in range n. So here I would like to write a dummy index, right? So let's first build the graph. I can do it like this. Build the graph. So here basically is a for loop. So for say u, v, start, end in edges, right? So it's graph, because it's directed, so we just write graph u append. So we're going to use VSE. So here I'm using list. You can use tuple here and here, right? The same thing. So now let's look at the run of Dijkstra's algorithm. So for clarity, I would like to put these 2 lines here, right? So this is running Dijkstra's algorithm. So this is very standard while heap. So we are going to do pop. So get the current time and the node. It's heap q, heap pop from this heap h, right? Then first we check if u is n-1, the destination. So we are going to return t, right? And otherwise, so we check if the node is thin. If this is already thin, so we're going to continue. Otherwise, let's mark it as thin, and then look at its neighbors. So for VSE in graph G of U, right? Then we are going to use a relaxation. So this is actually, in general, so the relaxation is this. So the distance, if distance by U plus D of UV is less than dV, right? Less than dV. So we are going to replace dV equals du plus duv. That is, if we find a node by way of which we can have a short distance, we update this. D is the distance. So this is a typical one. But here you can combine the hint 2 and hint 3. So what we do is, first, if t is less than or equal to e and thin, so I mean not thin, right? So let me add a parenthesis. So it means that so we can still visit the node V, and V haven't visited before. Then the time to visit, the earliest time, heap Q, heap push. The earliest time will be the max of current T, and the start time plus 1. This is the finish time, right? Plus 1 is the finish time. That's why I mentioned that. So this assumption simplifies the problem because it's the same, right? We just consider the max of TS, then you all add 1. So here, this is a node, right? So if during the process there is something returned, it means that we can finish or we can arrive at the last node. Otherwise, so afterwards, we are going to return -1. So that's the full code using Dijkstra's algorithm, right? So let me first test the 2 argument. Let's see, heap push, yeah. So I forgot this H. Yeah, it passes the 3 cases. So now we can submit for generic case. Yeah, it passes all the cases. So with that said, basically we finished the coding part. So if you want to have track the full details, you can do some print, right? So for example, you can print the status, right? The age and current TU, right? So let's do this. T and U, right? So it's better to put it here and then print the current status. That'll be enough, right? So you can run that. So for example, for this one, its current TU is 2, right? So we achieved. So similarly here, right? So that's the status of this U. At time equals 5, you can achieve. And here in this example, so because you know 0 has no outgoing edges, so the H remains this, and finally you get -1. So with that said, I guess that's it for the current video. So in our YouTube channel, we have a playlist regarding graph problems. You can practice with that playlist. Among that playlist, there are a number of problems which can be solved using Dijkstra's algorithm. With that said, thank you for watching.